Good morning everyone. This is Balram. I think some of you know. How many of you attended Sonnet classes? Please raise your hands for machine learning. Sonnet machine learning. How many of you attended? Now it is going on. How many of you know machine learning concepts? Okay, you may not write the exam. But how many of you know machine learning concepts? Machine learning or data science or deep learning or whatever. And SIH is also there. I think you may participated in SIH or in any way. No. So this is new. This is new concept for you, right? But I hope all of you know the database concepts. Database. Any database. It may be MySQL or Oracle or SQL Server or anything. Any SQL concepts. I think all of you are aware of them. Okay. So Java programming also good. Am I correct? Java is also good. Okay. So Java, DBMS, these two are good. What about the Python? How many of you know Python language? Okay. Numpy concepts. How many of you know Numpy concepts? Very few. Pandas. Numpy, you don't know Numpy means, obviously you may not be able to understand the Python. Okay. So visualization, meaning that matplotlib. So this is the status. Okay. Now, yes, today we are starting the preparation for the company. I think you know the company, right? What is the company? Vadvani AI. Did you see what is there in that site? Yes, sir. How many of you opened that site? The first step is, if you get an offer from one company, first you should go through the website. What are the products from that company and what are the services provided from that company? So you have to understand these concepts first. And then your profile. What is your job profile? I mean requirements. Data science, statistics, probability, linear algebra, calculus, and then Python. Next, hands-on machine. No. Hands-on data science toolkit. It is not hands-on machine learning. Please see that message properly. Hands-on data science toolkit. So you should understand what is the data science toolkit. The actual data science toolkit is different, and from your company perspective it is different, right? So the actual data science concepts are, first of all, we have to understand the data, handling of the data, that comes under the big data concept, that is Hadoop, and AWS managing the data by using cloud environments, that is a cloud environment, that is AWS or Azure or something. And next step is the analysis of the data. First storage of the data, next analysis of the data. Analysis of the data comes under the SQL-like concepts. SQL-like concepts. By using SQL, we can analyze the data. Analysis means summarization, visualization, all these comes under the analysis. Okay, getting insights from the data. That can be done by using your regular SQL and database concepts. Okay, and then analytics. Analysis is different, analytics is different. Analytics comes under predictions. The analysis will give you the summary on the existing data, that's it. Calculation, there will be some standard formulas. If you apply this formula, you will get the result. But predictions are little different. It is also based on some calculations, but we will estimate the future data. We will estimate the future data, that is called analytics. That is also called the predictive analytics. Please remember these technical words. They may be useful in your exam or in your interview. Predictive analytics. Analysis means analyzing the data by using some analysis tools. The analysis tools are SQL, MATLAB and Tableau, or some other concepts are there. So all these are the data analysis tools. Analytics means predictions. Predictions comes under machine learning. Actually data science is one part. Data science is a big field. Inside that there is a big data, machine learning, deep learning, all these are involved. Actually big data is separate field, machine learning is separate field, deep learning is another field. Reinforcement learning, this is another wing. So if you combine all of them together, you will get the data science, original data science. So original data science toolkit will give you so many tools, so which includes the Hadoop, Spark is also there. Okay, Spark, and all these concepts are included, and along with that you have to go for, yes, you have to go for the next level, that is the machine learning. The machine learning is completely based on the statistical models, statistics, and then you should go for the deep learning. Deep learning completely mathematics. Most of the concepts are related to mathematics in the statistics perspective. That is deep learning, right? And then you can go with the large amount of data, handling large amount of data by using the deep learning. If you want to handle the deep learning projects, you will have large amount of data. How to handle that large amount of data? That is by using, again you should go for the next level, that is GPU. We can introduce the GPU, okay, DZX servers, and they are also useful for some level. Beyond that level you should go for the big data concepts. Again you have to combine these two in the higher level, that is at the last level. But from your company profiles, meaning that their projects, based on their projects, they are concentrating on the machine learning, deep learning concepts instead of the big data. You just go through the site, you will understand. And image analysis, statistical analysis based on the tabular data. Tabular data handling is there, and also the image analysis and classification projects are also there, right? Now we have 4 days in our hand, and in these 4 days how much we can cover, that we can, okay? And mathematics and statistics related concepts, that will be handled by Yunus sir, and the machine learning, deep learning, myself and Priyanka madam and Kamal Vijeta madam, she will also come in the afternoon session. So we will handle the machine learning, right? So we will cover maximum whatever we can in these 4 days, right? For the initial step, don't think about the higher level. For the initial step, you have to write one exam, that is in the multiple choice questions. In that, most probably you will get the probability, statistics, linear algebra, and all these mathematical stuff will be there. Some concepts of machine learning will be there. Once if you go through that, in the interview, all these concepts will be very useful. For examination, they are useful for some sessions, last sections, but for the interview, it will be very helpful, right? We designed the course like this for these 4 days, right? So first we are starting with Numpy. Today we are going to cover Numpy, Pandas, and then Matplotlib, and then exploratory data analysis, EDA, meaning that how to take some data from the table and what are the data repositories available. And then afternoon session we will go with the machine learning algorithms like regression, classification and other concepts. Okay, tomorrow we will start the different concept that we will announce based on the today's session. So actually we have to plan according to your level, right? So that's why we can cover these concepts today. Okay, please cooperate and I'm handing to Priyanka madam to cover the Numpy, Pandas and EDA concepts. And if you have any questions, any doubts, please ask their questions and clarify your doubts. Okay.
Good morning, everyone. I'm really happy to be with you all. So anyways, first before I begin, I would like to share you all the best for the upcoming interviews in the preparation. You are going to write for Vadhwani AI, this particular exam, entrance exams or preparation, what all you are going to do. So I find that this particular session is for you to give you basic knowledge about data science toolkit, right? So I am going to handle this module whereby I will be explaining about Numpy, Pandas and EDA. Now before actually I begin with, like, why are we here to learn Numpy and Pandas? Now that's what is very crucial for you to understand. Okay, so before I begin, let me have a quick interrogation session with you. What do you understand by data science? So if you can come up, I will be getting an idea on what extent you have this knowledge. What is data science? What do you mean? Like in your own words you can tell me, there need not be a bookish definition. Analysis of data. So in your day-to-day life, where are you using data science? In your day-to-day life, can you give me some examples where we are using data science? Google, can you elaborate? Exactly. So basically, all of you surf with this Amazon shopping, your Netflix, everything. So what are all these things, those marketing gimmicks and all, these recommendations, the advertisements that pop up based upon your search on the Insta, all of these are nothing but applications of data science. Okay, so it is basically you are trying to research with your data and offer the best to your client based on his or her taste that would improve your business, right? So that's what we are going to learn about, how you can use the data so that you can use that analysis of the data for the betterment of your application, for the betterment of your business. Okay, that's what we are going to do when we learn about data science. So you have to learn the tools that will be used when you want to work with the data. Okay, such tools are Numpy, Pandas, and using those you try to explore your data, you try to analyze your data and make the data help you or benefit you for whatever application that you are doing. You are understanding? Like for an example, no, because if I talk about this, let me give you a simple example. When I work with machine learning concepts, when I work with AI concepts, you always want to build models. Now what is like that model? For an example, I would like to build a model. Let me take a concept which you can understand better. If I want to build a model wherein I just give an input picture or a name of a student, and then the model should predict me whether this student is eligible for elite finishing school or not. Okay, you are understanding that, right? So basically prediction is what we are going to do, but what role data science plays into it, what part the data science is going to do? The first thing is you have to train your model with sufficient amount of data. So when I talk about data, an entire data set is given to me for your batch, okay, say 21-22 batch, and I will be getting an entire information like name of student, picture of student, father name, address, you know, your SSC marks, inter marks, all everything relevant to you. Now when I am designing a model which is relevant to selecting a particular student for my elite finishing school, do you think all of these things will be in, like your address will be beneficial to me? Your father's name will be beneficial to me. To what category of OCBC you belong will be beneficial to me. What fees you are paying for that year is beneficial to me. No. Then what is beneficial to me? So basically say you are 2-1 marks, 2-2 marks. If you have given any entrance exam for that finishing school, okay, if you have got those marks. So obviously what I am working now, to the data set that is given to me, I am trying to filter it out. I am trying to explore the columns, if I can say. I'm trying to, right now I call that as columns. Later on we'll go for technical terms. So I'm trying to filter out the columns which are best suited for my model. I'm not going to take anything garbage out of it. Understanding. So what I am doing now, I am working with my data to make my model more and more good, more and more effective. So that's what we are going to do today. Okay? We are going to play with the data. We are going to see what best you can build with your data. Okay? So for that you have to learn about various tools like Numpy and Pandas. So that's the reason of today's session. Okay? So the first part that I am going to deal in today's session is about Numpy. Okay? So we just start in a moment. Okay everybody, now let us start with Numpy. Now before I work with Numpy, let us give a brief revision to what are the various data structures that you work with in Python. Lists, tuples, dictionaries, sets, right? So what is the difference between lists and tuples? Okay, good. And list is something like an array that you have been learning, right? So now here in Numpy, you know Numpy is a Python package for an n-dimensional array. So what do you understand by ND array or an n-dimensional array? What is a list now? One-dimensional. So first thing is, why are we going for this n-dimensional array? Like what is the difference between Numpy array and a list? So yeah. Yes, so obviously I have listed there an n dimension. So apart from that guys, list is going to store a heterogeneous data for you. You can store data of various data types, whereas Numpy array is going to give you a homogeneous densely packed data. Okay? It is going to be faster in nature when compared to list. Basically Numpy arrays will be used where you go for huge mathematical calculations and you have a homogeneous data of int or a float type to work with in a huge quantity. Okay, so basically you can directly process the Numpy array using vector operations, which is not possible with the list. Okay, list is like reference to the object. Okay, whereas it is not the case with your Numpy array. So that is the reason we are going to learn about these n-dimensional arrays more. So basically you know in like deep learning applications, you are going to work with huge amount of mathematical data. So you require a certain data structure to work with which can help you to calculate effectively at a fast pace and make use of these huge mathematical data that you can work with. That is the reason we are going to have an n-dimensional Numpy array with us to work with it. Okay. So Numpy is a numerical Python, the elaboration is numerical Python, and it is a Python package for n-dimensional array or an ND array that we call it, right. Now, it provides an array and it supports mathematical functions. Okay. It, as I told, it is a homogeneous collection of elements or a uniform collection of elements. Now, an array is characterized with the data type and the shape, okay, and the shape of an array is a tuple of integers giving the size of an array along each dimension. And what do you understand by that? When I say the shape is a tuple of integer, so there is always a predefined memory which is allocated for your Numpy array and it gives you the dimensional shape. So as I told, it is n-dimensional. Your data need not be a one-dimensional array. It can be two-dimensional array, it can be three-dimensional array. So based on your x, y and z axes, what is the dimension? It is going to be reflected when you give the shape of that particular array, right. Now see here, this is the Numpy array structure. As you can see onto your screen, it describes the memory with the following attributes. The attributes are, say, data pointer, data type description, shape, strides, flags. All of these we will study them in detail. So as of now, a broader overview Okay, this is your NumPy array structure. Now, these are the various flags that you can use with your NumPy array, like writable, aligned, update, copy, etc. Now, you have got various methods as well. All of them, we'll see them in detail. I'll be seeing with in them, I'll just let you know in detail. Now, these are the various data types that you can work with the NumPy. So, as I told you, it is homogeneous data holder. Okay. So, what are the data types that it is going to support? It can support a boolean, which can give you true or false value. It can give you an int I, which is a platform integer. It can be either int 32 or int 64. If you have got various memory allocation issues where you have to work with certain confined memory, then you can individually define your int as int 8, int 16, int 32, int 64, or else, and if it is a signed integer, you can go for int. If it is an unsigned integer, you can go for uint. Okay, in that again 8, 16, 32, 64, and then if it is a half precision, single precision, or a double precision floating point number. Okay, I need not go much into detail. I think this is okay with you guys. Yeah, right. Now, before we actually create arrays out of NumPy, now before I start this, see, this is going to be a doing and learning thing. Okay, so all of you, I need you to open your Google Colab. You are all okay with Google Colab? Yeah. Please open Google Colab and do it along with me so that you get a better idea. It's just like viewing will not help you out. So do it along with me. You have any doubts, you can approach. NumPy as NP, basically you can use anything, but that's a standard global convention to call it as NP, makes a better readability of any other global code as well. Okay, so import NumPy as NP and then you create a NumPy array. Now there are various ways in which I can create a NumPy array, like I can go for arrange method or I can go for array, reshape method, etc. So we are going to see one by one how we can create an NumPy array, okay, n-dimensional array. So the first thing is the general syntax wherein I am going to call upon array method out of the NumPy package. So here you can see I am just using np.array as the parameters I have to pass on the list. So please do that along with me and create a first NumPy array. So following up the syntax, create the array np.array and pass on the list of elements. You can also pass out the data type while you are beginning. Okay. So as I told you, your NumPy array should have a data type associated which is uniform in nature, homogeneous in nature. So if you are not passing on any d type there, by default it is taken as int. Okay. If you really want to go for a float type, then you have to pass on d type as float and observe the changes in the output, guys. So you can see that on the first output you got simply array 1, 2, 3. So what dimension array did I create? 1 dimension array, right? Okay, it is also called a vector. 1 dimensional array is also a vector, right? So now I created another one wherein I have created a floating type of an array. Done? Next. The second way where I can create a NumPy array is by using arrange function. Basically, we use this arrange function when we have got a huge range of data to work with. Okay, so for an example, when I am going to generate a sequence of elements in a particular range and then return an array, I am going to use arrange function. I have to give my start of the range, stop of the range, followed it, it's not necessary, but I can also give the steps in that range. Like I can give a range from 1 to 100. If I want all 100 of them, I am not going to provide any step size, right? If I need it as say 1, 3, 5, then I am going to give it a step size of 2. So like that I can give the step size if I want differences in my or the steps in my data. So this is what I am going to do very simply using an arrange function, creating an array of 10 values, okay, from 0 to 9. So you can see here, what did I give? NP dot A range. Now did I give any stop value or a start value? I didn't give any start value, guys. I gave a stop value. So as by convention of Python, it will take from 0 to n minus 1. So if I am giving an n value as my parameter, it will take till n minus 1 because it counts from 0. Okay. So same thing, I didn't give anything over here, I just gave a stop value. So by default step size is 1 and it starts from 0 and said 9. Now I have now created another one. What is that? That's a two-dimensional array for you. So what did I do here? I passed on two parameters inside a list. So I used arange function to create these two dimensions of my array, right? So I used arange of 4 twice so that I get a two-dimensional array. So 0, 1, 2, 3, 0, 1, 2, 3. Okay, rows and columns. So now this is like a matrix. One-dimensional array was like a vector and two-dimensional array resembles like a matrix, right? Are you with me? You are all doing? Yeah. Now, there is another method by which you can create a Numpy array. We call it as a reshape method or a reshape function using the reshape function. Now, it gives a new shape to an array without changing its data. So, whatever data it is, you can create, you can change the dimensions of an array by using this reshape function. So, as a quick example, you can see I first created a one-dimensional array using arange function. So I gave arange of 9. What it is going to give me as an output, guys? 0 to 9 as a one-dimensional array. But to the same, if I want to create it as a 3 by 3 array, okay, 3 by 3 array if I really want it, then I have to just take that data range and use reshape method. So dot operator, using dot reshape method, I am going to pass on the size to what I have to reshape that. So one dimensional array is now going to be written as 3 by 3. Earlier it was 1 by 9, right? And then now it will be a 3 by 3. So you are all with me? Yeah. Can I go to the next one? Now, you have got zeros and ones. Now, basically, this concept will be useful to you in your deep learning concepts where you will go for paddings. Okay? When you have got paddings with zeros or ones or whatever it is, at that time this concept will be useful to you, whereby you will be using inbuilt methods of Numpy called zeros and ones and fill that with whatever dimension is needed for you. Now, basically, why are we working with dimensions? Again, in the concept of AI and deep learning, you will be working with filters, guys. Okay, kernels or filters when you work with images. At that time, you require n by n matrices to work with. So that is the area where you will actually use Numpy. Okay, in your application point of view, I am talking about. So that is the place where you will be using especially zeros when you are going for padding inside an image. Okay, so with respect to application also, I am telling you what are the benefits of all these functions. Now you can see here on your screen, I have clearly mentioned what is a one-dimension array, two-dimension array, three-dimension array. I know you all know that, but few new things that you must notice here is how the shape is reflected. So see the one-dimension array, how the shape is reflected. It is, shape is inside the parenthesis only 4. So that means what? 1 is the row, that is by default. It is going to give you the columns. Okay, so columns will define you. I mean, if it is 1 by n, so only n will be given in the definition of a shape. So you must understand in that way. Okay, and look at the axis, guys. There is only one axis for a one-dimension array. We label it as axis 0 by default. Okay, now coming to two-dimension array, when you are going towards row size, it will call as axis 0. These things you must remember to work with further methods. Okay, So axis 0 is while you are moving towards the row side, and axis 1 is while you are moving towards the column side, because that's a two-dimensional array. Look at this shape. Shape shows as 2, 3. So number of rows are 2 and the columns are 3. Similarly, for a three-dimensional array, you can see as you are moving towards the row sides, it is axis 0. If you are moving towards the column size, it is axis 1. If you are moving towards the z-axis side, okay, then it is what? Axis number 2. And look at the shape over there, 4, 3, 2. So first row, then column, and then will come the other dimension. Clear with that, everybody? Now, I guess this is okay. Now look at this three-dimension array which has been created. So can you create that please now? Okay, create a 3D array. So use an arrange function of 24. So from where to where it is going to give you the values? 0 to 23, and reshape it as 4, 3, 2. So what do you understand by 4, 3, 2? 4 by 3. 4 by 3 is rows and columns. 2 is what? The z dimension. Okay? Done? Can I go for the next one please? Yeah. Now since you all have got an idea on Python, also the Numpy arrays support slicing, similar to the list that you have been seeing in your Python. Okay. So you all know the indexing, forward indexing, backward indexing. How many of you are familiar with this please? Please raise your hand. Okay, okay, fine. So maximum of you are familiar with this concept of forward and backward indexing. So can I quickly move to the next slide? Yeah, right. So try to implement that in your Google Colab. Now you create this particular data structure. What is this now? It's a one-dimensional array. Please quickly create this one-dimensional array. So what will you use? Arrange from? Arrange of 7. Arrange of 8. 8. Right. And then please could you print 1, 2 for me? The element I am talking. Element 1, 2. So what did you give over there? 1, 2, 3. Right. Next. Could you please reverse this particular one-dimension array for me? Like the elements are from 0, 1, 2, 3 till 7. I want from 7, 6, 5 till 0. Could you please reverse it for me? You did that? So what did you use? 2 colons and -1. Those who are new to this concept can please see onto the screen. Those who have done, I appreciate it. Well done. Okay? So 2 columns and -1. So there are few people who do not know these concepts. They can look onto the screen please. Okay? Right. Now, I think you all can do this. Okay. Now can you create a multi-dimensional array for me? Of size 4 by 4 and values from 0 to 15. The elements are from 0 to 15. The size is 4 by 4. You did that? So arrange 16 and right. Okay. So I think I'll have to keep this slide and work with it. So if I need to get a submatrix out of it, say 5, 6, 9, 10, then I'm going to print what and what guys? First I have to give the range of my rows to be printed. So if I want the second and the third row, I am going to print, 0, 1 and 2 and 3, like that how we number the rows. So I have 1 and 2, row number 1 and 2. So for that I gave there A of 1:3. And similarly for the column again, you know, I have 1 and 2, so I gave there 1:3. And I am going to print a sub dimension of those particular n dimensional arrays. This is a 2-dimensional array that you are working with, trying to slice it. Now, this particular indexing will be useful to you if you are working with backward indexing as well. It is up to the user whether to go for forward indexing, backward indexing. There is no compulsion. Okay. So onto the screen I have marked the indexes if you really want to go for backward indexing, backward slicing as well. Okay. Okay, without wasting much time. Now we have to work on this one. This one is something different. Okay, so what is this? This particular thing is going to be a 2-dimensional array. So can you just work on this particular exercise without looking onto the code onto the left? People who are new to this concept can look over here. Okay, just create a data, any random data. So how many are, what is the size of this particular array over there? What is it? 56. So can you please create it using an arrange function? The elements can differ. Try to access them. Try to do this particular part in magenta over there, like 20, 22, 24, 40, 42, you know, every alternate value from that particular n-dimensional array. Try to take that out. Okay, please work on this. Accessing submatrix was very easy, right? Even the third one, but the last one where those magenta squares are there, try to do that. You have to access what it is inside second row and fourth row, 0th column, second column and fourth column. Now look at this. You should be doing this with me, guys. Okay? So what did I do over here? I created how many dimensional array here? 3-dimensional array. Now my x dimension is 3, y dimension is 3, z dimension is also 3. Okay. Now in this 3-dimensional array, I have just simply taken an arrange function and reshaped it as a 3-dimensional array, guys. Now I printed A first. You can see there, I printed A first. So what is this A? A is coming on to from 0, 1, 2 till 24, 25 and 26. So you can see how the 3-dimensional array is projected in an Numpy. Are you clear with this? So 3 dimensions. So where is the other dimension? 3 rows, 3 columns, okay. The other dimension is the first matrix, the second matrix and the third matrix over there. Okay. So now you see here, how do we work with this? Yeah. Right? So 3 dimension, 0, 1, 2 rows, the green one, 0, 1, 2, the blue ones, the columns, and 0, 1, 2, the z dimension. Clear everyone? Yeah? So if I want to print A of 1:3, 1:3, 1:3, what is that giving me? 1:3 in the row side is giving me what? Okay, what it is giving now? Please tell. So it is going to give me the dimension of my Numpy array with the values of 1 and 2. Okay, so the red block. And then 1:3 over there again is going to give me the row numbers 1 and 2. and finally I'll get the column number. So what did I get over there? 13, 14, 16, 17, 22, 23, 25, 26. So this is for you to understand when you are working with n-dimensional array, basically 3-dimensional, that what we are working here. The first thing that you will be giving as a parameter is the main dimension. Okay, which dimension of that particular matrix you want. Then give rows of the matrix and then you give the column of the matrix. So are you all doing with me? Please do it, guys. Create a 3-dimension array and work. Now, there are various ways in which you can access the elements as well, guys. Now this is something new. Please have a look, everyone. So you can see here, I created one and I have created an array over here, right? Now, B is something A with all these conditions. So what do you understand by this? Yeah, Boolean means now if the condition is true, then only those values will be given inside this particular variable called B. Okay, so if I am having A of those values, so first check inside A to the corresponding position what are the values which are true. Those values will be given as a list to B. So you can see 3 is true and then 2 is true according to the position of index, and then 71 is true and 45 is true. So that's how it is getting projected here, print of B as 3, 2, 71, 45. Are you all doing this with me? There's one more way where you can work with the condition. Now in this, I am putting a condition that for a particular list of elements, all the elements which are greater than 10 inside that list should be given back to C. Okay. Now what happens if I don't give this, guys? If I don't put a square braces and an A over there, what happens? What will be C without that A and square bracket? Just true or false, exactly. It will be a Boolean list. It will not be a numerical list, right? After I have got a numerical list from this condition of A to 10, it is working in the same way what this has done. Mapping those true and false to A list and giving you the numbers out of that A list. So you are all doing with me, I am guessing. Yes? Yes. Please do that. So there are two ways I have shown here how you can go for conditional selection. Can we move on to the next one, please? Now, we'll now see about the various attributes of a Numpy array. The very first being the shape. So you all know what is the shape of an array. I already told you this, right? Represents the shape of an array, but it gives you as a tuple. So with that you have to understand that there is a fixed size for every Numpy array that you are going. Okay? Are you clear with that? There is a fixed size, there is a size to everything. Why? Because you are working with numerical data basically. Okay? And entire data that you are using in that Numpy array is homogeneous. So there is no need for any changes to the dimension, to the shape of that particular n-dimensional array. I need not waste much time with this. Now coming to the interesting part. We are going to now deal with an attribute which we call it as a stride. Any of you? What is a stride? Don't read that and tell me. What is stride? So stride is actually the tuple of bytes to step in each dimension while traversing an array. To put it simple, you are just jumping on from one element to another inside an array. Okay? So basically, you can move, jump column wise, you can jump row wise. So how much memory you are supposed to traverse? Okay? That gives you the stride. So once you see the example, you will understand it better. So just see here, we have created a how many dimensional array, guys? 3-dimensional array of size 2 by 4, right? So now you can see here, printing A I have done and then I have created shape for it and then I printed stride for it. Okay. So what is this stride telling you? So what is the answer for stride here? 48, 12 and 4. Now please see, to jump from column to column, suppose if you want to go from 10 to 11, one element size, here it is int, so shall I take it as 4 bytes, right? So from 10 to 11 what should be the stride? 4. That means from any column, I mean say column number 1 to column number 2, if I want to move, it will take me around 4 bytes. If I am traversing around the row, if I want to move from row number 0 to row number 1, then what should I do? Now before I explain it to this, try to understand this concept here. Any n-dimensional array will be stored as a data buffer in memory. This data buffer is contiguous in nature. Contiguous means sharing the same boundary. It is homogeneous and contiguous. So this particular 0, 1, 2, after that will be 3, 4, 5, 6, 7, 8, 9, 10, 11 as a data buffer. To you it looks like a Numpy pattern, but it is when it is storing it is a data buffer. So now tell me, if I want to move from row 0 to row 1, then how many strides do I have to take? Say 1, then 4 bytes, 4 bytes and 4 bytes. So what it is now? 12. Okay? And then this particular, because we are working with a 3-dimensional array, to move from one dimension to another. How many such strides, guys? 12 into 4 times, because it has to traverse 4 rows and then move from one dimension to another. So 12 into 4. So that's how it is 48. So when I print the strides of A, it is first going to print me what? So similar to the shape of an n-dimensional array. Inside the shape as well, what it gives you first is the shape of the z-axis. So same thing here. It is going to give me the stride of dimension, then stride of rows and then stride of column. Clear everybody? Please do this along with me. This is something new, it's a new concept for you. Any doubts with strides, guys? Look over here. The next example, what it is? What type of array it is? It's a 4-dimensional array that I have created, right? So now what I am having here? Dimension 0, 1, 2, 3. Yeah? So now what is this stride? Stride. To move from one dimension to another, then what is the column type, row type, and then what? The entire dimension. So what is it? See here, to move from one column to another as usual, 4. To move from one row to another, 16, 4 into 4, 16. To move from one block to another, 48, yeah, 16 into 3. Understanding, guys? And then from move to one dimension to another one, 48 plus 48, 96. Everybody, stride is clear to you even in 4 dimension, right? 4 dimension, you have x, y, z and say k. Okay? So first will be kth dimension, then z and then x is to y. Okay? Right. The second one is, so the first one that you saw as attribute was the shape of an array. The second one that you saw was stride of an array, and there are many which you can do it on your own. Endim, what is endim? Gives the number of dimensions of an array, very simple. Data gives the memory address of that particular array where it is stored. Size, number of elements inside an array. Item size, size of each element in bytes, n bytes, size of the array in bytes, and then T, which gives you the transpose of an array. So these are all attributes. I leave it on you to work with. If you want, please make a note of it. Okay? So these all, please try to use these attributes of a NumPy array on some examples and do it on your own. Okay? Any doubts so far, guys, on utilizing these attributes in NumPy? The difficult ones I gave you good examples. Okay? D-type. This is one important attribute which will make use in Pandas. So D-type will give you the data type of an array. Okay? I am not making you do all this, you are going to do it on your own. Okay? Make a note of these attributes and please try for it. If you have got any doubt, let me know. I think viewing itself makes it very simple to use, right? Now, coming to arithmetic operations. Arithmetic operations will be performed on corresponding elements of array. Okay? So it's more like you feel like it's a matrix type of an operation. You really feel so? No, they are basically vector type of an operations. Okay? Now, look at that. So what are these two arrays? Are they of same dimension, guys? So they are both two-dimensional arrays. So what are you going to do? You are going to add you are going to first tell what is A, B, add them, subtract them and multiply them. So please check if you are able to do and get the same. Now tell me what is happening with A into B.
It's just multiplying element by
So, it is not matrix multiplication, it is a vector multiplication. Element by element multiplication it is. See, vector addition, subtraction, matrix addition, subtraction, they are same. But matrix multiplication is not same as vector multiplication. So here what we are doing is element wise multiplication. Clear everybody? Yeah? Now, broadcasting. See, a NumPy array has got one important thing to work which we call it as broadcasting. So normally if I take a one-dimensional array and then add two-dimensional array to it, in other things it will just give you an error. Correct? Dimensions unmatched. Alright? But that's not the case here with NumPy arrays. So what NumPy arrays does is it duplicates the array with lower dimension to match to the higher dimension array and then it adds it or subtracts it, whatever it is. Okay? So this is what we are calling it as broadcasting rules. Okay? So NumPy verifies the dimensions are matched or not. It internally does that. It will not produce you an error over there. The smaller errors will be repeated or broadcasted to match with the larger arrays. Okay? That's one important feature. This is one more distinguishing feature between a NumPy array and a normal array. Okay? Next. Just have a look. Here what I am doing, guys. I have taken two arrays. The first one is 2-dimension. The second one is 1-dimension array. I am going to add that. So can you predict me what is the result of A plus B? What is the result of A plus B? 11, 22, 14 and 25. So the second array is broadcasted to match with the first one. So similarly the other activities are carried out, A plus B, A minus B and A into B. So see the result for yourself and verify if they are okay. Are you with me, guys? Please respond, it is becoming more monotonous. Okay? I am a bit rushing because we have many things to cover up. Okay? Right. There are various other methods that you can use in NumPy array which have been posted onto your screen. Just have a look. Out of them, the important ones we are going to do. Okay? The first one out of it is Argmax function. Sorry. Argmax, you all have worked with Argmax before itself. in Python, right? So what does Argmax tell you? Gives the index of the maximum value out of an array. It gives you the index. If you are using argsort, it sorts telling which index should have been in that position. It will not give you the value of the sorted array. It will give you the index positions of the sorted array, which would make that array sorted. Understanding? Similarly, argmax and argmin. It will not give you the maximum value or the minimum value. It will give you the index with the maximum and minimum values respectively. Okay? And similar is as as I told, argmax, argmin and argsort. Now you can see here, I have created an array with this. So what is argmax of A? Which one is the maximum value out of this, guys? I want you to do this with me. 71. So what is the index of 71 there? 4. So 4 is reflected. What is the minimum value here? So what is the index associated? 5. Now argsort, sorting it with which sorting will be by default ascending, right? So what makes this the array sorted with ascending order? Placing which index first and which index at last. Okay? And then as type. As type is a method if you want to cast from one data type to another. If you want to change from int to float or float to int, and that at that time you are going to use as type method and pass on the parameters to what you want to change. Clear with this? Type casting is possible. Okay? Can I move to the other one? Yeah. Now, Argmax using on itself is very easy, but Argmax has got an important feature. You can use it with axis. Basically, when you are going for n-dimensional arrays. So if you are moving in what direction and you want a minimum value or a maximum value in that particular direction. So see here, what is axis of zeros, guys? I already told you. Towards the row when you are traversing. So you see here, I have created an array and I reshaped it as a 3 by 3. So it's a 2-dimensional array that I have done. So you see when axis is 0 means it is going towards row size. So what are the elements towards row size, guys? 13, 2 and 21. So what is argmax of this index? 0, 1, 2. Argmax. Row size. Row side. Row side means direction of row. But it will be sorting the column only. Okay. So direction of row is axis equal to 0. Moving from 13 till 21. So which one is highest? 21. Index of 21, 2. Understanding, guys? How many of you are with me? You are able to relate. What about the other people, guys? See, when I say axis equal to 0, I am moving in the direction of the row, but I am sorting that column only. You are with me, right? So the second one, 4, 71, 45. What is the index for 71, guys? So 1. Similarly, I have 5, 0 and 65. 65, 2. So you can see here 2, 1, 2 is actually sorting you in the direction of the row, but you are actually sorting the columns. So that's how Argmax with axis is useful. Understanding, guys? So if I want to do the reverse position, if I want to traverse along column direction and I am sorting the rows, so I should give what? Axis equal to 1. So one such example is here, guys, axis equal to 1. So what I am going to do here is, I am going to move in this direction, direction of columns. So 13, 4 and 5, guys, which one is the biggest one? So what is the index? So here comes the 0. Similarly here 71, index is 1. So 1. Here it is 65, index is 2. So are you clear how Argmax can be used? See, if I am using Argmax without any axis, that means over the entire array, it gives me the biggest value. But if I am using in an n-dimensional array with an axis, then within that direction, it is going to give you the index. You should not confuse with this. Clear, everybody? Shall we move to the next one? Right. So the next one is this fill function, copy function returns you the copy of an array. I need not go much in detail. Now another two which are important for you while you work with statistics. Okay? So it is cum prod and cum sum. That means what? Cumulative sum, cumulative product. What is cumulative? Adding one element to another. Similarly, multiplying one element with another. Where you will be working with this? When you find out the mean. Yeah? When you find out the mean of a number, then probably you will have to add entire elements in the list and basically uses of it in mean. Okay? So cum sum and cum product, based on your application you can use it if there's a need to find out cumulative sum and cumulative product. Okay guys? Then next I have diagonal. Diagonal method is going to give me specified diagonals. You are going to specify the offset, you are going to specify the axis, you are going to specify how many diagonals you are going to go for. So as you can see, I have created a range of 16, 0 to 15, and then shape is 4 by 4, this particular first thing, and I printed it. Now I really want to know the diagonal. So the diagonal elements, guys, you all know, no? Diagonal matrix. So 0, 5, 10 and 15. If I want to know diagonal of 1, so after this guys, after this is your 0th index. For diagonal it is the 0th index. What is your 0th index? The middle one. 0, 5, 10, 15. If you want to go for diagonal of 1 guys, then this one. 1, 6, 11. Diagonal of 2, 2 and 7. Diagonal of 3 will be 3. Similarly, negative indexes if you want to go down. Clear everybody? So diagonal elements if you really want to pick up. Anyways, I am not going to give you the second example. We are lagging in time to go for pandas. Dump or dumps. Dumps a pickle of array to the specified file or returns the pickle of array as strings if you really want to know. Okay, then this method you can go for where it is storing the bytes of your array. Okay. Then this is what a dump and a dumps does for you, right? Flatten. Now this is an important concept guys, okay. So basically if you have an n-dimensional array, can I have your attention if you are done with the last one please? Yeah. Where will you use flatten? Why do you need something to be a single dimension? Very good, very good. Especially when you are working with images. Image, how is an image? You have it as a n-dimensional pixels. But when you pass it to a neural network, you have to work with a one-dimension array. So at that time, after performing various levels of processing to it, you need to convert those n by n data to a one-dimensional data. So at that time, you will be using a flatten function. Okay? So what is this flatten? Flatten will return a copy of array which is collapsed into one dimension. Clear everybody? Fill array. Filling the array with a scalar value. Again for padding purpose. Next. Item. Copy an element of an array to a standard Python scalar and return it. So you can see. Okay. Then item set. Item set, inserting a scalar into an array. Okay. And whenever you are inserting a scalar into an array, you make sure the D type is matching because array should be of homogeneous type. Okay, so whatever scalar you are casting into that array should be first typecasted and then given. Okay. Now, few statistical functions: sum of an array, maximum, minimum, mean, variance, all, any. Okay, all of these you have worked with already. Okay, so these are all various methods that you can use and work on within a NumPy array. Okay, and okay, already we have worked with reshape. I already told you reshape. Now ravel function, ravel method and repeat method, guys. So ravel will return a flattened array. What is the difference? Flatten, ravel. What should be the difference? Almost same thing it is doing, no? Then why a separate method? No. Flatten will give you the copy. It will give you a copy of the array. This might, this changes the original array. This works with the original array. Clear, everybody? That's why two methods. Sometimes you don't want to change your original data. You just have to work for some various reasons and don't want to hurt the data with you. Okay. Then repeat if you want to repeat elements of an array. Okay. Reshape, I need not explain it to you. Now, resize, please have a look. Resize will change the shape and the size of the array in place. Important. Reshape, resize, again like flatten and ravel. Okay. So what is reshape? Returns an array containing the same data with a new data shape. But if you really want to change the entire shape and the size, then you have to go for resize. Clear, everybody? When to use reshape, when to use resize, when to use flatten, when to use ravel. Okay? Now what are we doing there? Reshape. What is this? Matrix. So dot product we are going to do here, right? Dot product of two-dimensional arrays. Then next, what is this? Sorting. So these are the various methods. I am just listing you one by one what are the different types of methods that you can use from a NumPy package. What is this? What is this? What does it do? Converts a dimension of arrays into a list. Print it as a list. And then what about this? Changes the dimensions. Okay, swaps the dimension. Transposes. Then what is this? Creating a view. What you are doing in this? D is equal to A of 1 comma. Means what? If it is an n dimension array and you really want to see only the first dimension out of it, then you can view it. Okay. Yeah. Just have a look over here. What is happening over there? What is happening in this? We are slicing this and we are viewing it. So what is happening here? Sorry. 1:3, 1:3, 1:3 we already did in the beginning, right? So this is going to give 13, 14, 16, 17, 22, 23, 25, 26. What is happening over here? What is happening over here? Yes, it is going to take the steps and give you back the result. So you can see here 0, 2. And after here this is skipped, the second step. 6, 8. And then this is skipped completely. And then what do you have? So why this is skipped? In the dimension also, we are omitting one dimension and taking the other. Not only in the rows and the columns. Clear everyone? So this was about Numpy. So what was this? It was all about mathematical calculation. Right? Is there any data that I am working with? Any data given to me and I am working on it? No. It's just, I can say, entry of a particular column. Right? I am working with. That's it. Now, our next session will be going to be very interesting. It is Pandas and we will be working with real-time data. Okay? So, quickly shall we start for it? So, all of you with your collab books on now. Okay, this is going to be an interesting session. Okay, ready with that? Right? So, these are for our Pandas session. For data analysis, we have got a separate library in Python, which we call it as Pandas. Okay. Now, it takes the data and creates a Python object with rows and columns, which we call it as a data frame. You all are familiar with the name data frame? So, our data frame has got rows and columns with it, right? A table kind of a thing. Fine. It will take the data and will create a table out of it, which we call it as a data frame. Now, Pandas, basically it is column oriented. Why? Because data is stored in terms of column. Like suppose if I am marking attendance as well, I first have a column number, serial number, and then a roll number, and then student name, and then the attendance. And I just fill in with that. So, it is more of column oriented. I don't have like names onto the rows written. It is always column. Into the column I fill up the data. Okay. So, it is column oriented. Data is stored and retrieved in terms of columns. Able to read only the relevant data when you work with the columns. It provides high performance and easy to use data structures. Now, basically if you Pandas is an abbreviation for panel data, okay, tabular data, okay. So, panel data we call it as Pandas, which is an economical term for multidimensional data. Clear with that? This was introduction to Pandas. Now, getting started with Pandas. So, because it is again a package, you have to import Pandas as a global convention PD, okay. So, please import Pandas as PD before you work on it. Now, check for the version of your Pandas. Just see if it is available. If you are working on a Jupyter notebook, or just have a look at the version of Pandas. 1.3. So, when we created this PPT, it was 1.1. So, probably 1.3 for you? 1.35. Right. Anyways, anything is okay. Guys, please pay attention here. Pandas, there are two types of data structures. You have different data structures for Pandas also. If it is a one-dimensional data structure that I am talking, I call it as series. If it is a two-dimensional data structure, I will call it as data frame. Okay? So, when it is a one-dimensional, the size is immutable over here. When it is series, the difference is the size is immutable. But if it is a data frame, then the size is mutable. Okay? That is the difference. When it is a one-dimensional data structure of Pandas, we call it as series, and series is immutable in nature. It is a labeled array of different data types. Okay? Unlike a Numpy array, you can have heterogeneous elements inside a series. Clear with this, guys? The difference between a Numpy array and a series. Okay? Numpy array was homogeneous. Series can hold heterogeneous data types inside it. Okay? But it is immutable. value is mutable. You can change the values of the series, but you can't append anything extra to that. Okay, you cannot increase the size of your series. But data frame, if it the two-dimensional data structure of Pandas, it is mutable in size as well as mutable in the value. Okay, and again it is a heterogeneous tabular data structure with its labeled axis. Now when I call labeled axis, it means towards the columns will always have their index or names with it. Okay. This was about introduction to Pandas and types of data structures that we'll use in Pandas. Okay. Now, we are trying to create now a one-dimensional Pandas data structure. What is it? Series, right? So, series is an object of Pandas library which is designed to represent one-dimensional array-like structure. So, you can see here, you have got the data inside it and then the index of it. Similar to list, similar to Numpy array, correct? Now, how do you create a series? You create a series by calling a series constructor and passing an array which contains the values as an argument. So, very simple. All you have to do is use this syntax, guys, all over here. Please, I am going to take, I am calling here Pandas, but if I imported Pandas as PD, I will call here PD. PD.series, make sure S is capital, guys. Okay. Series, data equal to none, index equal to none, d type equal to none. As of now, it is a none type of a series. But when I create it, it will be like this. Import Pandas as PD, and I created a series of some list of parameters, and this is what will be the output. All of you please do this with me. Create a series. Previous slide, there's nothing, it's just a basic syntax. I didn't pass any data. It's just a syntax that I am discussing. I am using the same syntax to create a series now. Okay? All of you please do that. Any random elements, you take it and create a series. Create a Pandas series with any arbitrary values and check what is the structure of series looks like. What are the things that you observe in the output which are extra to what you have given? Index. So base and data type. So by default, the series will, when you create it, it gives you the type of the data which is present inside it and what? The index, right? Was it possible in list? No. Okay. Next. Please print the axis, shape and dimension of your series. Try to find out axis of the given series that I just created, shape of this series and dimension. So, axis may what it will give you? The range, है ना? Minimum where it starts, where it stops and what is the step size. Okay, and then shape, what does the shape look like, guys, here? Just it is giving 10 comma, linear. So, it is a one-dimensional array. The size already we discussed it in Numpy, right? 10 comma means there are 10 columns, okay? Sorry, there are 10 rows and there is only one column here, okay? And then what is the dimension? One dimension. Are you with me, guys? Did you all do this? How many of you want me to go to the next one, please? Because I want all of you to work with. Are you with me? Can I move to the next one now? Yeah. Okay, guys. Now what am I doing here? Please do that. Before, I have not specified any data type while I created the series. So by default, all my values were given to me as int. Now please change them to float. What is the difference? The role of decimal point coming there into picture, and the data type is now changed to by default. What was it earlier? Int. Float 64 means? Right. Okay. So by default that is there. Done with that? Same will be the axis, same will be the shape, same will be the end dimension. There will not be any changes when you do it to the typecasting. Okay? Next. Please do this. All of you, create another series. What is the difference between this series and the previous series, guys? It's a heterogeneous data type that I am using there. It's a mixture of int and float. So please create any element that you like with a mixture of int and float numbers. Did you do that? Try to print the shape and check for the values that it gives when you print that particular series. Print that series. By default it was giving you D type. After you print this mixed thing, what it is giving you? So by default, what do you understand over there? Yes, by default the int type is converted into float type. Are you clear? That's how data type errors will not be there when you are working with series. Okay? You can use a mixture of numbers there, and by default they will be typecasted inside a series in the pandas. Okay? Right. Look for this, guys. Please try to do this. Create another series now and just add some strings to those. Add some strings to those elements and now get the series printed and check for its data type. Object. So the moment it is only int and float, it was typecasted to float. The moment now it has got some characters with it, then it is giving me object. So by default int and float are also typecasted to object. Clear, everybody? When this will be useful? When do you think this particular feature of pandas useful? Why this is useful? Yes. Suppose I am doing a job of collecting a Google form data. Okay. So there are many places where we ask for some numerical value. Okay. If you are not given any radio buttons to select from and there is a typing thing, then a person can type 1 as number 1 or 1 as ONE1. But that does not mean there is no data in that. If you just go for D-type filtering, ONE1 just gets away, which we don't want because data is valuable to us. So that's the reason that number 1 and ONE1, both of them if you work with pandas will be treated as a data. And later on we will see how to work with such kind of mixed data as well. Are you clear, everybody? So this is a very unique feature of pandas, wherein even if it is a character, then automatically all the int and float values are also converted to object, so that the data is being utilized. There is no error that is showing because of D type. There is no filtering that we are doing there. Are you clear? Right? So that's one important feature that we have learnt. Next. Now, series re-indexing. Changing the index as per your choice. So by default, if you just see where does the index start from, guys? 0. If you want to change it, then have a look. While you create a series, then as a parameter you pass the index. All of you please do that with me. Now you create a series with the name of few cities, like here I have taken Hyderabad, Chennai, Bangalore. I want to create a new index label for them. So I just pass that on with my parameters. Please do that. Try to do it on your own first without looking the screen. All you have to do is randomly pick up 3 cities and give 3 different indexes to them. So what is D type by default? Object, because we are making use of strings over there. So you all did that? Did that? Can I move on to the next one? How many of you are still doing? 1. Okay. Next. Just have a look. There's one more way to it. What am I using here, guys? What am I going to use? I'm going to use index attribute here. So first attribute of Pandas now you're viewing. What is it? Index. So whatever series that you have defined, take index attribute of it and give it a new name. Just have a look. Here what I am doing, I am giving index as a string as well. So I can label these H, C and B. Okay? When I am passing as an index. In place of any numbers, I can go for any characters as well. Are you doing with me? Yeah. 2 ways. Any method is okay. Either use an attribute or directly pass index into the parameters. Anything works. Can I move on to the other one? Yeah? Just have a look. If I want to retrieve Hyderabad out of it, I can either go for location of this series. What is the index of this Hyderabad? So what am I doing here? S of 0. So either I can go for index or I can directly use reference through an index name. Index name, index. Both are different things here. Please do not confuse. When I am creating a series, I can still call its element through its index. But just for my convenience, I am giving that index a name. Okay? So are you able to retrieve any element out of your series? Just retrieve any arbitrary element out of your own. Okay. Now, coming to data frames. So that was all about series, guys. Series was one-dimensional data structure. The main movie starts here where we are working with data frames. Maximum amount of time we are working with data frames, which is our tabular data. Okay? So you can see here, what is the difference in the syntax here? With respect to series, you have got columns as well. And the name here is data frame. When you are doing it, make sure D and F are capital, otherwise it gives you an error. Okay? Data, index, data type and a new one which is column. Next. Please create this. What is it now? What did I do? Try to do this. Can anybody explain me what am I doing here? Creating a data frame of what? Yes. What did I get over there? 3 rows and 1 column. So what is it same as? It is same as series. Huh? Right? 3 series. Right. So you can see here, like look for the shape of this data frame that you created. What is the shape it shows? 3, 1. Look for the axis, please. Same thing. Start, stop, okay, range index and range index again. Yeah? Understandable everybody? Are you doing this with me? We are just trying to create a data frame on our own. And checking for its shape, checking for its axis. I didn't pass any index parameter yet. Okay? Simply working with the data. So you all with me? Are you done in your notebooks, guys? Can I move to the next or should I wait for you? Let me know. Okay, right. Just have a look now. What did I do over here? Same thing that I did for the series thing. Now I created something with a mix of int and float. What you can observe here is again the data type is changed to object. So the features of series are also valid for the features for data frames. Okay? Next. Now have a look. What is this? This was not possible with your series. This is something now different than series. What is it? What are you doing here? So what it will create for you? Two different columns, right? So you please see here what is happening. Two columns have been created for you. What is it? 4, 1. And then you have got the data type again as object. You can work with this more, but first start creating this data frame where I am passing two lists here. Are you working with me? Got it? Now see here, everybody. Passing 3 list, what it is doing now? When I print a P, it gives me a value error. What is the value error? Shape of the pass value is 4, 1. Indices imply 4, 4. So now what should we do? How to rectify this? What is happening over here? What did I do over there? Yes, it is taken as an index. A is taken as an index. All of you please try to do this. The earlier one was giving me an error, right? So I simply rectified it. Please do this, everybody. What new thing are you observing in the output? You have to tell me with this.
We are getting row index as 56 and column index
And
as 8.
row index, column index and what? Column name. Column name. Okay? That was very important for us now when you are creating a data frame. Now, here in the side, I am creating a data frame out of a dictionary. Why do you use a dictionary, guys? When you have a specific value to a particular key, okay? The key values cannot be, the key names cannot be duplicated inside a dictionary. So out of that, so it's similar to that key, what are the values? So it's similar to creating columns out of it. Okay? So how do I create a data frame out of a dictionary? Okay, where I have name of a student, marks of a student and value of the marks, whatever it is. And you want to create a table out of it. So that's what you are going to do over here. So you just see here, I am just going to take key as column and then elements will be taken as your values. All of you please create a data frame out of a dictionary. So now you can see here what is the shape of this data frame, guys. What is the shape of the data frame that you are getting here, guys? So now it is a proper data frame that you are going to see with 4 rows and 2 columns. The columns, as you can see, have been automatically labeled now. They are labeled columns. and the name of the labels are the equivalent to your key value, key name, sorry. Okay? Clear? So this creates a proper data frame for you, and as usual, because it's a mixed data type inside your key values, the data type object is going to be, the data type is going to be an object data type. So you are doing this? You are doing this? Yeah. Now, how do we specify column name when you are creating a data type? That was with dictionary. Okay, fine. With dictionary there is one way. What is the other way? See here, what I am going to do here is, I just created a list of my data, okay, and I passed it to the data frame method as a parameter. The other parameter what I can give to the data is the column name. One way is to do with dictionary. This is the second way, passing list as your data. First way we saw passing dictionary as your data, how to create data frame with the dictionary. Now we are creating a data frame with the list. All of you please do that. Take any arbitrary list, create a data frame out of it and label that as a column. That is your task. Don't look onto the screen. Do it by yourself. If you have any doubt, then you look onto the screen. Create any arbitrary list, create a data frame out of it, and then a label, specify a column to that. What is the difference between this particular thing and the last one that you did? Can I directly use this list here, like how I have used dictionary? What is the difference between when you pass dictionary as a parameter and list as a parameter? See, yeah, dictionary mein you didn't specify, you see here, any columns, because by default the key name will be taken as the column name, guys. But when you are passing list as your parameter, then you have to specify the column name there. Are you clear, everybody? That's the difference, how to use dictionary and list in your data frame. Yeah? So you all did this, you created a list, you passed out, you created a data frame out of it, and you specified a column with it, right? The next one. Have a look, what am I doing? What am I doing now? Now your task is to create multiple lists, pass that as a parameter, don't look onto the screen, create any arbitrary multiple list, create a data frame out of it, and try to specify columns out of it. Here I have not done, you specify them. All of you please do that. Any two arbitrary lists, create a data frame out of it, try to specify the columns. Is my pace okay? Are you able to do each and everything now? Yeah? Did you do that? Did you did that task? You specified the columns over there? Right. I think you have done this. Yeah? Same thing you did, no? Because you are passing two lists, you have to specify their two columns. Right? Next. Please do this. Try to do this. Create a data frame from two lists of different sizes, please. You will be doing. Create a data frame using two lists of different size. Done? Good. Now can you see the method that I have used here? You have done it well and good. There's one more way which you can do. What did I do here, guys? Yes, I have used list as my dictionary values, key values. There are many ways where you can create a data frame. There is no restriction, guys. Whichever you find it good, you do that. Okay? So there's one more way which I have just explained in this particular example, where I have passed list 1 as the key value of my first key of the dictionary. Okay? What is happening now? What is happening when I did this? Nobody pointed me that. What is that? Value error. Arrays must be of the same length. So when I am using a dictionary, I am getting this value. Problem. Right? So now what do I do? When I want to create a data frame from two series of different sizes, if the series will not match in length, automatically through Pandas, missing values will be taken as none values. Okay? So to avoid value error, what you should do? Create it as what? Series. Understanding, guys? So when I am using those dictionary things or list things, it is giving me index error, value error, because they are not of same size. So to avoid that, see there might be the cases where when I am retrieving some data out of a Google form, many things will be left blank. You know, most of us, we are so busy. If somebody is asking us a survey Google form, we will just first check for where are asterisks. Yes or no? We don't have much time to fill in each and every detail. Where there is an asterisk, we'll fill it. Where there is no asterisk, where it is not mandatory, we just leave it off. But then that does not mean few of them might not have filled it. Okay? So there are places where some of the users might have filled it, some not, some may not have filled it. But then that should be taken as a data. That should be taken as a data. So any value which is missing cannot be avoided. So it is taken as a null value. But to create such tabular data out of it, you have to use series. Take every element of every column as a series and then append it into a data frame. Clear? So all of you please try this. Use two series and create a data frame out of it. Now the advantage of using series to create data frame is clear. When to use series to create a data frame, when to use list to create a data frame, when to use dictionaries to create a data frame, it should be clear now. Okay? So please use two series and create a data frame out of it. Now because the dimensions were not matching, now you can see here, the first one shows grape, banana, apple. There is no fourth one here. So automatically what do you see? The fourth one is appended here with NaN. NaN, or in some versions it may call it as Na. Okay? So none values, missing values. Question marks sometimes. Missing values can also be question marks. Okay? So that's the shape of your data frame. Shall I move on to the next? Yeah? Now, creating data frames from a dictionary of empty values and then updating it. If I am creating a dictionary of empty values and then I want to update it, can I do that? See, what I am doing here, C1 again empty list, C2 values are empty list, C3 again empty list, and then I am creating a data frame out of it. And you fill it. Please do this. There is a missing code there. There is a missing code there onto the slide. Please fill that and execute. Create a dictionary of empty values and then create a data frame out of it. So by these exercises, I really mean to tell you where you should use lists to create a data frame, where you should use dictionaries, where you should go for series. These things you must be aware. What is the difference between series and data frame? What is the difference between a Numpy array and a series? So all of these things. Why do you go for Numpy arrays over already available lists as your arrays? So all of these are your interview based questions, guys. I hope you are all clear. If you are not clear on anything, do let me know. I will repeat it for you. Okay, the pace is fast because stipulated time is less, but if you are really not understanding anything, stop me there, feel free for that. I will repeat that for you again. Okay. So did you all do this? Did that? Any arbitrary value, fill in. See ya. Okay, I just filled in with something. You can fill it with any arbitrary value. And what you get is a data frame. Now, when we have a data frame with us, you always have to create copy of it before you proceed. Because when you are changing, you don't, you don't want to manipulate your original data. Okay? You just want to work with a copy of your data. So there are two ways by which you can work. One is deep copy, another is a shallow copy. So first see the differences between them. The last bench is, I am audible to you? Am I audible? Yeah. Now see here, a deep copy. A deep copy is the one where we simply use df.copy method. Okay? And for a shallow copy, inside the copy method, you have to mandatorily give deep equal to false parameter. Then only it will be a shallow copy. Now what is the difference between deep copy and shallow copy? If it is a deep copy, it will be copied into another object with no reference to the original. Means what? You are not changing the contents of your original data structure. But if you are directly working with a shallow copy, you are manipulating contents of your data. So based on your application, if you are short enough that your data has to be manipulated, work with shallow copies. Just if you are exploring your data and you really want to do something new with it, then you go make a deep copy and then you work with it. Afterwards, when you are sure enough, you can replace them, then you work with your shallow copy. Clear with this, everybody? Right? So let's create a data frame. All of you will do a simple exercise on deep and shallow copy. First, create a data frame with 3 cities. I have taken Hyderabad, Chennai, Bangalore. You can go with any. Please create a very small data frame. I just want to see how deep copy and shallow copy works because I don't want to destroy the original data set that we are going to work with it now. Create a deep copy. You create a deep copy. In that copy, change Hyderabad to some other name. Okay? I have created there, the first element is Hyderabad. You change it to some other thing. Create a deep copy. Replace Hyderabad with something else. Any other city, any other name. And check for your original data, check for your copied data. Print it again. I simply change the entire column there by just picking up 0. Okay? What did I do here? My name, deep copy name was D copy. D copy of 0 I am replacing with there as Andhra. So that means the entire column has been taken, 0th column. So all the 3 things have been replaced by Andhra there. Okay? But then when I take a shallow copy and I try to do that, just have a look. The deep copy has changed the names for my deep copy, D copy, but the original data structure was same. It is still reflecting Hyderabad, Chennai and Bangalore there. This D copy is my deep copy, city names is my original data structure. So replacing this hasn't done anything to my original data structure. Whereas for the shallow copy, when I replaced it, it changed my entire data structure as well. The data frame values have been changed. So when you are not short of any pre-processing that you are doing to data, always as a prerequisite, create a deep copy and then work for pre-processing of data. Do not change the data as it is. Clear? Right. Now, creating data frame by loading a file. So now we'll work with the data sets. Okay? So you will be using comma separated valued files, Excel sheets, okay, or text sheets, and you can create a data frame out of it and work with it. You can also mount these files onto your Google Colab and work with it. Okay? So I told you to download a Toyota file. Did you all do that? You all downloaded Toyota file. Guys, how many of you downloaded? Please raise your hand. What about remaining people? How you will do? Please Google Toyota dataset in Kaggle and then you download that dataset. Don't download notebook. Download dataset out of it. And then we work with it. Okay guys, those who have downloaded, please mount your data onto your Colab. Please mount that CSV file, toyota.csv you got. Did you all get that? Yeah? Please mount that on your Google Colab. Mounted? Yeah. And from Google Colab, please import, you can automatically mount that in the folder section, or you can manually go for an instruction which is shown onto the screen and mount it. Give the place where you have to mount it. Done with mounting, everybody? How many of you are done with mounting? Please raise your hand, guys. What about remaining people? There are two options to mount. Either go on to the left side of the pane in the folder section. There will be a folder with a drive thing. You mount it. Or you can use this particular instruction. Any one is okay. Everybody, are you able to access your file now? Mounted? Yeah. If you have any problem, you need any help, please raise your hand, guys. Right. Anyways, you have to allow it as an access for your drive. All those things you can do it on your own, I think. Allow the access to the drive. Now, I want to display the directories. Then what do? I want to display the directories in my data set. What do? You require OS for that. So, please import OS in your Google Colab. Import OS and using list_dir method of OS, list the directories. So the directories by default in your Google Colab should be the drive and the sample data. Okay? If you are working with something else, it might show other thing. Here there are the screenshots are of for a Colab file. Okay? Then, guys, why this is important is, this step is important even if you are using a Kaggle notebook. In Kaggle, you can work on your notebook there and there. So the data set will be automatically downloaded there. You need not mount anything onto your drive and work. That's the beauty of Kaggle. That's why we want to work with it. Because no downloading, no storing, everything is there. So in that, if you want to explore your data, there will be several directories inside your data where your images are stored or your CSV files are stored. For those things, you have to see what are the directories in your data set. Because that is a task which is given by the client to you. You have to explore it. So first step towards exploring your data is to check for its directories. Next is choose a path that you want to go for. Okay? Here it will not be a big deal. All you have to do is copy the file that you are going to do and read it. That's where we begin. These steps are for if you are going for a higher end like Kaggle, we are working with huge data sets, then these are the steps which are there you have to work with. Then, yeah. Okay. This is not needed for you. Right. Now we'll come with our data set. Is your data set mounted on your Google Drive? Yeah, you are able to see that in your sample data. You can also store that in your drive and use it. The moment you use it in your sample data is after you finish the Colab, you cannot access it again. But if you store that inside your drive is that it will be easily retrievable later. Okay? So based on your application, you store it like that. Copy that path and then work towards, we can use it to work with that data set. Okay? So now about the data set that we are working, first The name of the data set is toyota.csv. So this is a data set given by Toyota company about its various car models. That's what I can understand as of the name. I'll explore it later. Okay? The size of the data set is 1436 by 11. How to find out size, that also we'll see. Just a brief history of what is going. If I open that Excel sheet, I can see now what are the number of rows in the columns. That's what I am telling you. I am not still working with any pandas. So this data set is about details of pre-owned cars and the properties associated with each car. Okay? Now, what are the variables? See here, these names, variables, attributes, features, columns, they are all interchangeable now. What it is? Variables, attributes, features, columns. All of them are interchangeable now. Okay? So what are the various columns of my data set as a layman now? What are the various columns that I have, or what are the, there is something unnamed, I don't know, and there is price, probably price of the car. If there's something unnamed, I don't want that column. I don't know what it is, what to work with it. Okay, so this is something I don't want. I would like to discard it off. That's the first thing that comes to my mind. Age of the car in months. Age of the car in months means with this you should analyze what type of data type should it have. What it should have? Int. My mapping in my mind. Okay. Kilometers the car might have traveled. So I thought there should be some numerical value with float with it. Right. Fuel type. It's an ordinal type. So it should be either diesel model or a gas model or a petrol model kind of. Category. Basically categorical data. Okay. Then HP, horsepower. Okay. Then color of the car, metallic color. Is it metallic color or a non-metallic color? So again, what type of data it is? Categorical. Categorical, metallic or non-metallic. Basically 0 and 1 here because there are only two categories. There can be more than two also. Then automatic. Is it automatic gearbox or a manual gearbox? Okay, again categorical. CC, size of the engine. So probably some value should be there in float. Doors, how many doors are there? Number of doors. So I find like some integer value should be there, 2, 3, 4, whatever. Then weight, what is the weight of your car? Again float. Okay. Now, let us now read your data set. So these were all about when I got to know my data set, these were all the things which I know about it. When I just look at it. Now let us practically look at our data set and see if that is the case what we have saw. Okay guys? So we proceed now. How do we read a data set? By using a method read_csv. But before that, please import pandas as pd, copy the file location, copy the path, and please read that file using pd.read_csv. pd.read_csv. All of you please read the file toyota.csv from your folder that you have put in. Are you able to read that? Please read. How many of you have read it? Good. Remaining people, please read that so that we are on pace. We everybody, all of us work together. Reading does not make it into directly converting it into data frame. But if you do pd dot, then it will directly convert it into a pandas data frame. Okay? Simply reading will not do. If you put pd dot read, then it converts it directly into a pandas data frame. Right. So everybody, how many of you are with me? Are you able to read? Please raise your hand. it makes me go to the next one. So almost maximum of you are able to read it, right? You are able to read your data. So what did you get once you read the data? A table kind of a thing, did you see? Yeah. Now, there's a very big thing. I just want to see how my data looks like. So say I want to know the first 5 samples. First 5 samples. Header of my data. So what do I go for? What does this mean? Header, if I want to know, if I want to see first 5 rows, then give head. But why am I using header here? See what is the value, what does header does for me? When header equal to 0, what is happening over here? Columns are projected. Then header equal to 1, then there is no column names which are projected. Instead, third row is also given to me, right? Similar is the case with header is equal to none. If header equal to none, then what is happening over here? I am getting column indexes, column names, and then a few amount of data. Okay? It's up to you whether you really want to go for header or not. Directly also you can move with the data. If you move directly, column name and data. First 5 samples, use head function. Header is different, head is different. Header is a parameter that you use while reading, whether you want to view the column names or not. Head gives you the first 5 rows of your data frame. Difference is clear? Right. Please display your data frame. We already named our data frame while we read it. Okay? Please display your data frame, print it. Once you display your data frame, what did you see? The first thing that your eyes should go on is the size of your data frame. By default, printing the data frame will give you its size. So what is the size of this? 1436 rows and 11 columns. Along with that, it gives me the labels of my columns as well. Okay? 11 columns. I think this first column is useless. Because when I work with Pandas, it automatically gives me my index name. Wherein here again an index is already given with an unnamed thing. So probably in my future, I just want to discard that. Okay? So next. I want to read my data frame now without this first column. Please do that. How do we do? And please all of you first copy this. Okay? Copy your data first. Create a deep copy and then you do, or else after bypassing this first index also you can create a deep copy. Because first index is basically useless according to us. Shows the index. So how do we do that? Everyone? To make the first column as index column, pass index underscore call equal to 0. Use this while you are reading your data frame. Because many of the times in our data sets there will be one serial number which is coming. But already through Pandas we have our serial number in an index form. So we don't want that. So while you are reading only, you can bypass your first column by using index underscore call equal to 0. Please do that. After you do that, don't directly start processing your data. Create a copy, deep copy. Don't create a shallow copy. Okay? Disadvantages of shallow copy already discussed. So create a deep copy and then work with it. So all of you bypass the first one. Now print and see. Now print your data frame and see. The first column has been bypassed. The serial numbers have been bypassed because you already have index in your Pandas, and then you have name directly starting with price. Everyone, Clear? Yeah. So as I told, please create a deep copy of your data frame before you actually start working on it. Clear everyone? Yeah. Let us be a little quick if you can. Now, let's check what are the attributes of your data frame. Are you with me? Yeah. So, please tell me what are the attributes of your data frame. Just looking at the data set you can tell. Price, met color, kilometer, all these are. But because there are 11 columns, you are able to see. If it's a very big data set, then yes. So, you go for this. Here I am just checking what is the index. So, data frame dot index. I am just checking the indices. It's up to me. If I want to check the columns, for rows I will use index. For columns I will use dot columns. All of you please check the features. Features can be row wise, features can be column wise, basically column wise, because that's where your entire data is being filled in. So, data frame name dot columns, you just type it on and it brings you out all the attributes relevant to the columns. If it's a big data set, manually you cannot see each and everything. So, data frame name dot columns. Are you with me, last benches? Are you able to retrieve the information relevant to column attributes, guys? You are with me, right? Yeah. Now, check for the size of your data frame. That will be done through attribute called size. Data frame name dot size. Let me know the size of your data frame. Already by default Pandas gives. So it is, so what is it giving you? Product of 1436 by 10. Earlier you remember it was showing 1436 by 11. So we omitted, we bypassed the first column. So now we have 10 columns and 1436 rows. So now the entire size is product of rows and columns. Clear everyone? Yes. Check for the dimensionality of your data frame using the attribute called shape. Data frame name dot shape. So obviously now it will give you the matrix version 1436 by 10. Are you all doing this? Yeah. Important. Dimension of your data frame. Dimension of your data frame, guys, 2 dimension, because only rows and columns, that's it. There is no z dimension to it. Okay, so we are working with only tabular data, so n dim is going to be 2. N dim we also studied where? Numpy. Okay, now important one. What is it? Data frame dot values. Values attribute. It is going to return the Numpy representation of the data frame. So that's why we first studied Numpy and then I am going for Pandas. And I have elaborately explained all the methods which are useful in Numpy that we use in Pandas. Although I was a bit fast in Numpy, but there are n number of methods to it. The methods which we use actually, that I have elaborated well. Okay. So now you can see here, what are all these? I gave the data frame name dot value. So what it is giving me, guys? It was giving me a Numpy array of all the values of my data set. Clear with this? So if you are having only a data set with all numbers that you want to work with it, create a Numpy array which is more faster and work with it. Okay? Yes. Next, but important part, guys, here. Check here. What is Numpy array type? Why? Int is there, float is there, string is there. Had it been only int and float? Right. Now, next, to get values out of a single column of a data frame, guys. How do you do that? Check here. Out of your data frame, so what do you have here? I just randomly took HP column and I want to know its values. Can you do that for kilometer, please? Choose kilometer column out of your data frame, get all the values with respect to it. Please work with your data frame. The more and more you explore, you are able to retrieve all the values of kilometer, right? Like that you can see for whatever you want to work with. Now, to get the values of multiple columns, then what do you do? If you want multiple columns, comma, yes, comma you can use. So here I have taken HP and kilometer, please do that. If only I need only 2 columns out of that huge data set and I want to work with them, then that's how you should do. Please take, now you please take HP, kilometer and one more, go for CC. Go for CC. HP, kilometer, CC and get all the values. Are the last benches working with me? Any doubts? Yeah? This side everybody is doing? Yeah. Did you retrieve all the 3 values? Yeah. Now, these were about attributes, what you have seen. What were the attributes? Shape, size, values, all of these were attributes of your Pandas data frame. Now we will see about few important methods that you can use in this data frame. So as I told you, if your data frame is too large, you just want to see an overview of it, I just take few samples, starting samples of my data set. Then what do I go for? Head. So suppose if I am actually not passing any n as a parameter to my head, if I want to view first 20 samples out of my 1436, I should give data frame name dot head of 20. If I am not giving that 20, by default it gives me 5 samples. Try that. Data frame name dot head, data frame name and then get 10 samples for me. Try only a head method and second time you try for getting first 10 samples of data frame. First 10 samples of data set. Just view how your data looks like. On your screen I have taken first 6 samples of my data frame. Okay? If you want to know the last 5 then please do that. First 5 I have seen. Now I want to see the last 5. Achha, now look here guys, what is the need? You can ask me, ma'am, why should I see the first 5, first 20, last 20 or some random, why should I see? Because you want to pre-process your data. You want to see how your data looks like. The first thing, as I gave you and I began this session, I told you, you have to create a model for your elite finishing school. So there all columns were given. Name of student, address, father name, father contact details, all of those things discard. So discard those columns from your data frame. Take only relevant columns. So what columns you would pick up in your data frame? Data frame name, student marks second year, student marks third year, student marks finishing school entrance, and then you will work with it. Clear everybody? Now, you want to pre-process your data. When you want to pre-process your data, some things like this, see. Check for the first 2 samples guys in the doors column. When I saw the header, in the doors column, please check what is happening. So I have a data set which is huge, 1436, but there are some places where instead of number 3, there are 3. Does that mean that this data is not important for me when I am working? It is important, but I should do something for it. I can't work with these 2 together. When I saw the header, I saw there is in the med color, a row number 2, I have a NaN. What does that mean? So this column needs my attention guys. Are you understanding? What is the need? that I check the head, tail, a few samples. Which columns needs my attention while I'm working my data? So I find, as of now I find doors column need my attention and met color needs my attention. Remaining looks okay. Okay, remaining looks okay when I see head. When I see just head. Next. Check for the tail. If you have seen the tail, now what is happening? Age has got null values. So age also needs my attention. So doors, then met color, then age, then kilometer has got question marks. So now to pre-process, before I actually use this data and fit it into my model, I can't do that. I'll not get correct predictions because data has got a lot of null values, data has got a lot of mixed values that I have to work with. I can't directly give it to model. I can give it, but the moment I give it, it can give me wrong predictions. My accuracy is going to be affected. So I first need to pre-process the data. And for that pre-processing, we are using Pandas. Clear everyone? And second thing, because it was a data set I just explained you, student fitting into elite finishing school, you could clearly say, okay ma'am, you discuss address, you discard contact number, because you know what is that model. But once a client comes with you a new model which you are new to, how will you know which column is relevant to your model application or not? How will you know that 2-1 marks and 3-1 marks are dependent on each other or not? Means how the student studies, how is the progress. So if it is a new model, then you will have to see if I vary one column, is the other column varying? I want to see if there is some similarity between one or two columns. So this is where Pandas and EDA come into picture. Basically, this is the thing you do before you apply any data to build a model. Because if you directly put your thing, your accuracy result will be very poor. Okay? So pre-processing is something which is needed. So for pre-processing, first thing is explore your data using Pandas. That's the need. That's why you are learning this. Okay? Right. So now my eyes are now on doors, met color, kilometer and age. I identified 4 columns out of 10 columns. Yes, fuel type also, one missing value in the tail. So I identify now 5 columns that I may have to pay attention. Okay, out of 10 columns there are 5 things that I have to work on before I give it to my model. If I want to know any randomly in between, who knows? Because kilometer and age were not showing in the head. They were all showing proper, but in the tail it was there. So let me see some random samples. So for that, please check any 5 random samples out of your data frame. Check any 5. So randomly it will give you. See now when I see this randomly, I don't find any problem in my data set. But actually if I see the tail, there was a problem. So like that I have to identify every time where the problem exactly is before I actually fit this particular thing onto a model. Okay? Right. Now, that's all manual again. That is all manual again. Randomly it may not show. Probably it might be. So how do I work with? So working with this, we will see it more detail in EDA. Exploratory data analysis. That is one different part of a story. Today I am just going to teach you about Pandas. What you can do with Pandas. I will take a separate session on exploratory data analysis on the same data set, so that there will not be any problem. Okay? Now, there is one more method on Pandas that helps you to find out the type of data set. So what do you think should be the data type for doors? Actually it should be integer, but according to the data that you saw, why? Because THRE3 you saw, right? So you can see here, price is showing int, price is showing int. not a problem. Price should be a numerical data. Age is showing float, numerical data, not a problem. Kilometers. But what is kilometers, guys? You have seen the header of your data frame. Check the header of your head. Sorry, not header. Head of your data frame, you see? What is head of your data frame inside kilometers, guys? All numbers, integers. But what is this showing? And it's not something like anybody will write 6,782. Henna? So now what? Null values. Good. So even if you have null values, it will show you an object data type. So that's again a hint. Kilometer should be paid attention to. Understanding, guys? That's the reason D type will be very helpful to you while you are working with pandas. Second, you see fuel type object. No problem. No problem? No problem? Fuel type. It was a categorical data, guys. Fuel type as petrol, diesel, CNG. So 0, 1, 2. Fuel type should have 0, 1, 2. It's a categorical data. So again there can be some missing values. That's why it is again an object. So this also needs your attention there. So analyze your data like this. Okay. Then HP. HP again shows horsepower, numerical data. But it is showing again object. Again hint of missing values or null values. It can be missing values or null values. Okay. Then met color, float. Okay. And then automatic, int, CC, int. We are having NA, that is null value, missing value, both are different. When I show you unique values, I will explain you the difference. No problem. Good observation. So now doors, again object. And then weight, int. Overall data type, what it is showing? Object. Why? Mix. Okay, right. Then, see, as I told you, I will deal with all this in EDA. That will be a separate story. Right now, my aim is, like how I told you, what are all the methods in Numpy. I am focusing where it will be useful, those methods in elaboration I am telling. Okay. Next method is what? Count. What will count give? Count will give me non-null value, guys. Again an important indicator. All of you please do it with me. Count method on your data frame. All of you apply. Important part there is non-null objects. Apply it to column of age. Apply count to the column of age. See how many values you are getting. Tell me. 1336. What is your size of data set? How many rows? 1436. How many count is age showing? So 100 missing values are there in age column. You explored that. You can't view the data set, no? It's a humongous data set. So how do I identify how many missing values are there? So there are almost 100 missing values there. Because count shows non-null objects are 1336. I am still not bothered on whether 20 was written TWENTY or 2020. 20 was there. That is still non-null. I am not purifying my data still. I am just seeing if it is missing or not. Okay? Next. What is the minimum value for a particular column? Apply that to age. Apply minimum value. What is minimum value for age? 1. Yes. Okay. So what is the minimum value? 1 year, 1 year old car. Okay. Right. Next method that you can see. What is the maximum value? What is maximum value for the age of a car there? It is 80-year-old car. Okay. So these are all the methods that you can use to just get a overall view about various attributes, various columns inside a particular data frame. Okay? So now with this I got to know there are almost 5 to 6 columns which needs my attention. These are my inputs for my EDA now when I am teaching you Pandas. Okay? So I will have to work on these 5 to 6 columns in EDA. I got to know that there are almost 100 missing values where I have to work for age column. 2 inputs are ready for me now. Okay? Next. If you want to know overall sum of a column, why do I need that? To find out average value, if I want to know the sum, then please apply sum to the age column, guys, all of you. Now, mean value. Can anybody tell me now why statistics is coming into picture? Why? Why do you take? Why is my question. I know, to fill in your null values, fine, correct, extremely correct. But why?
So that the values related to the other values, you take the mean.
Yes, very good. Yes. So when I enter into this classroom, if I was a new teacher, completely new teacher to you, okay? So do I have to work with the poorest person here or the weakest person, or do I have to work with the strongest person? Both of them don't need me. The person who doesn't want to study will not study. The person who can study doesn't need me. He's far beyond me. So my focus is, what is the average? So when I came, I first explored my data. I asked how many of you know Numpy and Pandas. That was my first question. I saw average number of hands. Then I prepared my strategy for the lecture. So always it is average. It is always statistics when you work with data science. But what concept of statistics? And it is not always, see, I give you one simple example. Okay? I have my set of students here, guys. I randomly take my 10 volunteers. I ask for their marks in machine learning, mid one, for an exam. And I have this 11th person whom I forgot to give marks. What marks should I give him? Average of those 10. Okay, fine. I have these 10 students. I ask them their division of pass, grades. 6 of them gave A grade, 2 of them were B, 2 of them were C. What grade should I allocate to this guy? A. Mode. So where I should use mean, where I should use median, where I should use mode. Statistics is there, but where I should use, that is more important. For that, you require to study about distribution of data, that we will see again in EDA. Okay? So again, statistics plays an important role, and all the statistical methods are present in Pandas. So quickly moving on, mean of a column, median of a column, and standard deviation of a column. What are all these? Again in EDA, each and everything I'll teach. Okay? Are you clear with this? Right. Variance as well, unbiased variance. Okay? So mean, median, standard deviation and variance. Now this is something which is a very important method for us, guys. What does unique help you to? Returns unique value for a particular column of data frame. Why would we use this? And?
Is it categorical or?
And? So people are telling me to find out null values. Okay. What are the various unique values that you have in that column? So specifically, if you see, if I call upon door, when I saw the header, there was only 3. But there's every possibility that 4 was written as FOUR, 2 was written as TWO. Can I scroll through 1436 rows? So what do I do now? To the doors column, I apply unique method. Please do that. To the doors column, you apply unique method. Here I have have applied it to age onto the slide, you do it for doors. So what did you get? So 3, 5, 4 and the numbers in words and in numbers. So you could identify there that these are the things which needs my attention. These are the unique values that were filled for those columns. Like that for every column you must see. Okay? This was about age. Why age is not showing any null value there? Why age is not showing any question mark or NaN? Because it only consider unique values that have been filled. Clear everybody? So what are the unique things that were filled under that column? It is going to display you there. Clear? So this is a very important method and we are going to use it. Then memory usage, to get memory usage of each column, which is the biggest column amongst all. So I cannot see anything differentiation over there because all of them are of the type object. Next, if you want to sort the values, when will you use this? When would you like to sort a particular value?
US cars in the market.
Yes, if you want to know which one is highest, which one is lowest, when you are going for medians, okay? Yes, okay? At that time you really want to sort your array, that column array, okay? Ascending, descending, if ascending is false, it gives you a descending order, okay? Inside parenthesis, make ascending as false, you get a descending order. If you are not giving anything, it will be by default an ascending order. Any column. Sort values method. Information, very important. So what do you think info will give you?
Overview of the data.
Yes. It is going to give me an entire overview of the info is a very important method, everybody. Please do that, info. So info gives me the total values, how many non-null values are there, how many data types, different data types are there in my data set, and what is the memory usage. Basically all in one it is, info. So just I press an info, I get every detail of what I have seen so far, okay, except unique values. Okay, info, did you all observe the info values for your data frame? Next, drop. So as I told, discard the address of student, discard the father's name, discard this, discard that. So for discarding any row or column, you will use a drop function. Okay, so how would you use this? Drop, unnamed, axis equal to 1, in place should be true. All of you must try this, okay? But you should make sure you are doing this in a deep copy, okay? You are making in a deep copy. If you really want to try this, guys, please make another copy and do it. Because drop means you will be discarding and then again we cannot use the same file for EDA. If you want to drop a particular column and see, make another copy, drop it and check if it is dropping or not. Okay? Don't do it right now because same copy we will be taking it forward for our EDA. Clear everybody? Right. You can also insert a column. Insert is one more method. Yeah. Insert is one more method which will help you to insert a column into a data frame. Don't do that right now. Use this again after you create a copy. So drop and insert, you tried for you today. In my next session, Pandas is still not concluded, guys. Okay? We'll use, if you can pay attention for 2 minutes, there's an important announcement. Yeah. See, Pandas and EDA goes hand by hand. So visualization of data, Pandas, both of them will use to do EDA. So there will be another session on EDA. So a few methods which are left for Pandas I'll cover there. I'll start with visualization and I'll extract an EDA. By the way, we will use the same data set. Okay? So till now, whatever I have taught, what is Numpy, why we are using, what is Pandas, how we are using numpys in pandas, what are the unique attributes of the pandas, what are the various methods that you are using in pandas. They're all clear to you? Any doubts for today's session? So I am still concluding here because of time problem, but then there will be one more session of EDA. I'll resume from where I have stopped because that's a continuation. There's nothing new that I'm going to do there. Clear everyone? Any doubts for today's session? Or you want me to repeat something in today's session for the next session? Is there anything you want a repetition before I begin the next session? That will be probably tomorrow. That will not be relevant to this, but try to understand, guys. Listen, once a new session is getting started for you, whatever output you will get out of this pre-processing now, that will be implemented in the model. So that model part and all ma'am will start teaching you from today onwards. We are still doing pre-processing, which will continue tomorrow. All pre-processed data completely will be taken by her and she'll build a model. Clear everyone? So we'll continue pre-processing tomorrow.